we are asked to graph this function, present everything, domain, range, x and y intercepts, asymptotes, the table of ordered pairs, the study of the first derivative, the study of the second derivative, the whole spiel. So the first thing I need to do is factor the denominator. Can anyone give us the factored form of the denominator? Please, anybody?
Would it be x minus 2, x plus 1?
Yes, thank you. So the first thing I have to write is that x cannot equal -1 and x cannot equal 2. Only now I can simplify, and the simplified form is 1 over x minus 2. Now I get my table going right away. So I have f prime, I have f of x in the middle, and I have the second derivative. So negative infinity to infinity, -1, 0, and 2, and I have to write that x equals -1 and x equals 2. The function does not exist. Because the factor is still left in, x equals 2 is a vertical asymptote, but the factor that disappeared is a hole in the graph. Then I plug in 0, and I see I have 1/2. I know that when the limits, and I have to write the limits at infinity, both of them are 0, which means y equals 0 is a horizontal asymptote. I have to determine this point, but when I plug in -1, -1 minus 2 is -3. -1 over -3, this must be the whole. Now at 2, I have to find this limit, and I have to find this limit. So with 2.1, this is negative infinity. But with 1.9, this is infinity. At this point, I completed everything I could find about, or I determined everything I could find about the function from the function itself. Now I have to go to the first derivative and later on to the second derivative. So I changed this into -1, or negative in parentheses x minus 1, x minus 2 to -1. Why? Because the numerator does not have x, and it's easier for me to differentiate. So now I will write this. It's much easier to differentiate. Now, if the numerator has x in it, I will have to use the quotient rule. But because it doesn't, this is so much easier to change into a power. So now the first derivative will be x minus 2 to -2, and the second derivative will be -2 x minus 2 to -3. Yes, I want to see this that is x minus 2 squared, and I want to see this that is -2 over x minus 2 to the third. I see that this is never 0, but it's also always positive. So then I have all the signs for the first derivative, everything is positive. Remember that this row has to work with this row. If they don't, something is wrong. 0 to 1/3, yes, it's increasing, that's correct. From 1/3 to 1/2, yes, that's correct. From 1/2 to infinity, yes, it's also increasing. From negative infinity to 0, yes, it's also increasing. Now, I study the second derivative. It's never 0, but this can be positive or negative, depending on x minus 2. If x minus 2 is positive, the whole thing is negative. If x minus 2 is negative, the whole thing is positive. So, to the left-hand side of 2, x minus 2 is negative. So with a negative in front, this will be positive, which means the function has to open up. Here, to the right-hand side of 2, this is positive, but there is a negative in front, so this will be negative. And the function must open down. These functions should not take a long time for you to figure out. So now I'm ready. Based on the table, that's all I need. I'm ready to graph the function. First, I have to graph the asymptotes, but this is an overkill. It's right here. This is x equals 2. And the point is, the open point is -1 1/3. Difficult to graph. Now, I read 0 going up, opening up to 1/3 through the hole, going up to 1/2, 0 1/2, and going up to infinity. Very easy. On the other side, it's coming from -infinity, opening down, approaching the horizontal asymptote. So this is f of x equals -x plus 1 over x squared minus x minus 2. Any questions? Any questions on this graph? Okay. Determine the maximum or extrema, points of extrema, or max min if you want, on a closed interval. So let's look at 38. If you have any questions, stop me anytime. And so I'm on page 5. Okay, 38. I have f of x equals e to -3x plus 8x, and the interval is -1, 2. This problem is not asking us to graph anything. What was it? 12, 13, something like that. Good. So this is, we're not asked to this has nothing to do with the second derivative, and it has nothing to do with the graph. So there is no need to graph, but you have to present a table with f prime and f of x. Do not create an interval. The interval is given to us. You cannot use anything else. So I have to find f prime. F prime of x, when I differentiate, I get -3 e to -3x and plus 8. I set this equal to 0, changing it first like this. And let me just rewrite it. So as -3 plus 8 e to 3x divided by e to 3x. This can never be 0. It's an exponential function. So f prime of x can be 0 only if the numerator is 0. -3 plus 8 e to 3x equals 0. I move 3. So I have 8 e to 3x equals 3, and e to 3x equals 3 over 8. I hope you remember that we need to apply natural log to both sides and bring 3x down, which is natural log of 3 over 8, or x equals, and I divide by 3, natural log of 3 over 8. I have to approximate it, because I don't know if it belongs here or not. I have no choice. I have to find an approximation for x. So we go here, and we have natural log 3 over 8, and we divide the whole thing by 3. Okay, so it is in -1 to 3, so it's -0.33. Good. Now I need to study the sign of the derivative. So here's our derivative. This is always positive. So in here, I'm going to put this in the graphing calculator and plug in -1 to see the sign to the left and plug in 2 to see the sign to the right. And then I will determine the function value at these points. But I need the sign of the derivative. This whole chapter is about the derivatives, the first and the second derivatives. So I go back to y equals, and I punch in, and I will punch in both functions because I need them both anyway. So the first one is e to -3x, and close the parenthesis. You know my parentheses are very important to me. Okay, plus 8x. So this is the function, and here's the derivative, -3. I only need the sign for the derivative, so I don't care for the denominator. Plus 8 e to 3x. Of course, -3x. Okay, one more time. So the first one is the function, that's correct. The second one is -3 plus 8, yes. So now I'm going to plug in -1, and I'm going to plug in 2. Okay, so the function is 12.1 at -1 and 16. And as you see, the derivative at -1 is positive. That's all I care. I'm not going to copy any of those numbers for the derivative, and then negative. But I will plug in -0.33 for the function. So 0.05. Okay, now I have to make sure that these two rows work well together. Otherwise, I have a mistake. And it makes no sense. Is this again the type of function that this calculator cannot handle? This is absolutely ridiculous. We encountered the same situation before. Okay, let me clear everything. Let me just do the function again. So e to -3x, and then plus 8x. Okay, one at a time. Am I entering this correctly? Yes. Okay. So second in table, -1, it's 12.1. 2 is 16. But how can -0.33 be 0.05? Okay, let's assume it's correct. Okay, let me put the derivative now. Okay, I'm checking the derivative one more time. E to -3x is e to -3x times the inner function prime, which is -3, and plus 8. -3 over this, the least common denominator, -3 plus 8. Oh yeah, that's correct. That's correct. I did enter negative. Okay. I think I did enter negative. So one more time, -3. That's how we catch mistakes. Plus 8. E to 3x, that's correct. Something is, okay. It was e to 3x, yes, that's correct. So all I want to determine is the sign at negative, okay, fine. I probably entered -3x. So that's correct now. So it is negative on the left and it's positive on the right. That's all I needed to know. Now it makes sense. Because I think I entered negative for the power. I'm pretty sure I did. That's why it made no sense. Okay. Yes, now it's correct. So from 12.1, it drops down to 0.05, and from 0.05 to 16. Everything works fine now. So this is the absolute max. It cannot be relative max at the endpoints. So this is the absolute max, and this is the absolute min. It's also relative min and relative as well. This one is nothing. It cannot be relative because it's at the end point of the interval, and it cannot be absolute max because there is an absolute max. It cannot be absolute min because there is an absolute min. Good. So that was a problem on studying a function on a closed interval, finding the absolute max, absolute extrema, absolute max, absolute min, and we also can mention the relative min and relative max. Okay. Now finding the linearization. Any questions before we continue to another problem? Any questions? Okay, can we work on the linearization problem?
Yes.
Okay, perfect. So let's continue. Um, 49. We're given find the linearization of f at x equals 3. Use a linearization such and such. Where is our function? Oh, I see. The function is up here. So f of x equals 2x to the third plus x. Find the linearization and use it to approximate such and such. So let's find the linearization first. Okay, there is another chat for me. Oh, yeah, okay, good. So if you remember, the linearization is basically a linear function that approximates this function near 3. So this is f of a plus f prime of a, x minus a, where in this case a is 3. So that's the formula. Good, so let's find f prime. So f prime of x is 6x squared plus 1. Let's find f of 3, and let's find f prime of 3. F of 3 is 2 times 27 plus 3, so that's 54 plus 3, I got 57. F prime of 3 is 54, 55. So 3 squared, 6 times 9 plus 1. Good, so now I have to just plug them in. So L of x equals f of a, 57, plus 55x minus 3. I have to simplify it as much as possible. So L of x equals 57 plus 55x minus 165. Combine these two, so L of x equals 55x minus 108, is it? 65 minus 57, I got negative 8. Okay, so this is the linearization of this function only near 3. It's a straight line. I can approximate the function near 3. I don't have to plug this in. I can use the approximation. I can use the linearization to find an approximate value. Okay, then it's asking us, use a linearization from part A to approximate f of 2.9. Then compare the approximation to the actual value of f of 2.9. So we want to look at f of 2.9 and at L of 2.9. and they should be very close. Of course, this must have some error in it. This will be exact. This will have some error, but it will be a very good approximation of the answer we get with F. Okay, so I'm going to go to y equals. I'm going to put the function in, which is 2x cubed and plus x. I'm also going to put the linearization, which is 55x minus 108. And I am going to plug in 2.9. The first one is exact. The first one is exact, which is 51.678. And the second one is an approximation, which is 51.5. They are quite close because 2.9 is quite close to 3. So this is the exact, and this one using the line. Using the line that approximates the function near 3. Any questions on this problem?